Hello friends, in this video we are going to discuss about total internal reflection on the basis of electromagnetic theory. Okay, so now let's start. Here you see the total internal reflection. First let us assume that assume a situation in which radiation is incident from a medium of higher refractive index, which is I have taken N1, on the surface of a medium of lower refractive index N2. Okay, so this is the incident ray. Okay, it is traveling in a medium of higher refractive index, and here you see, and it strikes the interface, the plane which separates the two medium. This is medium 1, this is medium 2, suppose, and this is this medium 1 is refractive index of N1 and medium 2 is refractive index of N2, and N1 is greater than N2. I have considered that way. Okay, then one part of this wave will be reflected back to the same medium. Okay, and one part will be transmitted through the medium, okay, of higher refractive index, like this, right? So here this Ki means the propagation of wave vector, the propagation constant of the wave vector, right? Incident wave, and this is same for the reflected wave, and this is for the transmitted wave, right? And angle of incidence is theta I, angle of refraction is theta t. That means the angle made by the transmitted, that means refracted wave with the normal, and theta r is the angle of reflection. That means the angle made by the reflected wave with the normal. Okay, so I have taken that way. Now according to Snell's law, we will get this relation. This is theta I, right? This is theta t. So n1 sine theta 1, n2 sine theta, n1 sine theta I, n2 sine theta t. And if you simplify this relation, we're gonna get this relation which is I have given as equation number 1. Now let me go to a new slide. Here you see. So here we have taken this Ki, Kt, Kr are the propagation vector of the incident, transmitted and reflected wave respectively, and which are nothing but Ei, Et, Er. These are the incident, transmitted and reflected wave, and their amplitudes are respectively E naught I, E naught T, E naught R. Okay, and the angle of incidence, this theta I, is increased. Suppose it is increased gradually, such that it is increased gradually till this theta t becomes pi by 2. Okay, so when you see this angle of incidence, theta I increases, the angle of refraction, that is theta t, also increases. So we have this theta I is increased gradually, so that this theta t is also increases when theta t increases, when theta I increases. Okay, and theta I is increased to angle, that is theta c, which is known as critical angle, such that theta t becomes pi by 2, right? Theta t becomes pi by 2. That means this is theta I is increased to theta c, such that this transmitted wave makes 90-degree angle with the normal, right? It becomes pi by 2. Theta t becomes pi by 2. Okay, so in that case, if we use these two values in this equation number 1, if you put here pi by 2 and here theta I is theta c, if you replace theta I with theta c, then you're gonna get this relation, right? And if you simplify this, then theta c will be equal to this. This is suppose equation number 2, right? Hope you have understood this. Now you see you have got these two equations, these four equations, 3, 4, 5, 6. So when E polarized perpendicular to the plane of incidence, we have already discussed these two cases, okay? Case 1 and case 2 in previous lectures, okay? When we have studied about electromagnetic wave in the electric medium, right? So, and this relation 3, 4, 5, 6, these are Fresnel's equation, okay? So this is the Fresnel equation for reflection for the first case, and for the second case this is the Fresnel's equation for reflection, and 5 and 6 are Fresnel's equations for refraction, right? Now here you see we have got this cos theta t. Now you see it has other form also, but I am not writing that, okay? So now let us obtain this theta t, cos theta t. So here you see cos theta t can be written as 1 minus sine square theta t, right? So here I have written this equation number 1 and 2 again. You don't need to write this because these two equations were in the first two slides. That's why I have written this is 1 and this is equation number 2. So just I have written here 1 and 2. You don't need to write it again once you have written. So now you see here you see n2 by n1 is sine theta c. So n1 by n2 will be 1 by sine theta c, right? So we can replace this by 1 by sine theta c. Then this can be sine theta t will be equal to sine theta I by sine theta c. So this sine theta t is replaced by this result. That's why we have got this. Now you see when suppose this incidence angle is now greater than the critical angle theta c. In that case here you see when theta I increases, right, then value of sine also increases with the angle, right? So in that case, if this one is greater than this, right, here you see, if you observe this, if theta I is greater than theta c, then value of sine square theta I will be also greater than value of sine square theta c. In that case, this part you can see that will be greater than 1. If that is greater than 1, then under root we're gonna get negative number. It may be, let it be suppose minus q, right? Because we're gonna get 1, then minus, we're gonna get a number here which is greater than 1. Whatever we get here, that's going to be greater than 1. And in that case, if 1 minus something greater than 1, then there must be a minus something, that let it be minus q. So if it is minus q, root over minus q, that can be written as root over I square q. I is the imaginary number. So that's why we can write this cos theta t is iq, right? Let me suppose this is not q only, this is suppose q square. In that case, this cos theta t can be written as iq, right? Let me take that way, okay? So that's why I have assumed that cos theta t is iq, right? Hope you have understood this. Now you see, just let me clean these things, okay, right? Now you see, for the first case, when E is polarized perpendicular to the plane of interface incidence, so I have taken this equation number 3, right? This is nothing but from equation number 3, right? So here you see, now in this equation number 3, I have replaced this cos theta t by iq, right? That's why we have got this. Okay, now you can see if you obtain the mode of this, right? You know, in case of complex number a plus ib, if you find its mod, then what you're gonna get? Root over a square minus plus b square, right? You get that? Hope you have got it, right? So similarly, a minus b, if you take the mode of this, then also you will get root over a square plus minus b whole square. Same thing, in both cases the result will be same, right? So that's why we have got that on taking mod square we have got 1, right? So if this is equal to 1, then we're going to get mod of or is equal to mod of oi. So which means that this incident ray is reflected back to the same medium. Okay, similarly for the second case also we can show this is equal, these two are equal, right? Which means, so the incident ray is reflected back to the same medium completely, right? So thus the wave totally reflected. This phenomenon is known as total internal reflection, right? And if you find the rate of energy flow, energy carried by this transmitted wave, this is the transmitted wave, if you calculate this, then you will get energy transmitted by this wave equal to 0, which means, so this wave is reflected back to the same medium completely. That's why energy carried by this transmitted wave we're gonna get 0, right? So if we calculate this is pointing vector dot n cap, which is perpendicular to the plane, unit vector perpendicular to the plane. So at the end you're gonna get 0, right? Hope you have understood this. So thank you for watching. See you in the next video. Bye bye.